When you think of engineering, you probably think of cars, bridges, and computers. The words biomedical engineering may elicit images of prosthetic devices and MRI machines. But I'm here to tell you that engineers aren't just building devices that live and work around our bodies and the cells that make us up. We are engineering biology itself. And we're doing it right here at the School of Biomedical Engineering at UBC. Now, in my lab, we like to think of human cells as mini computers, like your cell phone. Your cell phone has a processor that uses electric circuits and digital software to run the apps you love. And software is a program. It's like a set of instructions telling your phone's processor how to run those apps. Human cells also have a processor that tells them how to behave. It doesn't have any electrical parts. Their processor is encoded in the DNA. DNA is a molecule that carries information. It's a genetic code that cells carry around and read like a software code. And it's more efficient and more reliable than any computer hard drive ever invented. Just like software updates you get for your cell phone or computer, recent genetic engineering tools allow us to update the processor in our cells too. By reading, writing, and editing DNA, we can start to program what our cells do, even correcting diseases that are caused by mistakes in our DNA. We can also think about adding new special abilities to our cells, as we might download an app to update our phone. This sounds cool, but what we can do with apps relevant to human health and life is way cooler. Like car. No, it's not a motorized vehicle. It's an app for your cells, and it stands for chimeric antigen receptor. The CAR app is a protein sensor that sits on the surface of the cell and allows it to recognize cancer. Researchers can now take your blood and engineer the T cells, a kind of immune cell, to carry the CAR on its surface. The T cells, now called a CAR-T, contains this new app, which gives it the special ability to seek out and latch on to cancer. Once detected, the T cell triggers your immune system to kill it. Clinical trials are now ongoing to treat various blood cancers using CAR-Ts. And this is just the tip of the iceberg for the kinds of apps we can upload into our cells. Imagine other cool apps, like one to detect your blood sugar levels that could help you monitor diabetes. One that could let you see ultraviolet light so you can monitor your sun exposure. Or boost hemoglobin so you can set the high score at Grouse Mountain. Thank you.